Most people think of the digital economy as weightless. Software, apps, cloud services, AI tools, streaming, search, online work, digital payments. It all feels abstract, like it exists somewhere above the physical world. But that is becoming harder to believe because the digital economy is turning out to be intensely physical. It needs land, power, cooling, fiber, water, concrete, steel, chips, buildings full of machines, and huge amounts of constant energy. That is the shift. Data centers are no longer just technical facilities hidden in the background. They are becoming one of the core industrial structures of the modern economy. That is why data centers are becoming the new industrial core. Not because factories stopped mattering, but because more and more economic value now depends on physical infrastructure built to process, store, and move computation. People often talk about data centers as if they are just support infrastructure, a necessary background utility, a place where servers sit, a warehouse for the internet. That view is outdated because data centers are no longer just passive storage environments. They are becoming active production sites. They power cloud computing, AI systems, enterprise software, video platforms, search engines, financial systems, industrial data flows, and communications networks. That means they are not just storing digital activity. They are enabling it in real time. This matters because when a system moves from optional support to essential production infrastructure, its economic importance changes. It starts attracting capital differently. It starts reshaping geography differently. It starts competing for resources differently. That is where data centers are now. For a long time, industrial power meant things like steel, oil, rail, electricity, factories, ports, and roads. Those systems shaped economic strength because they determined what a country or company could build, move, or produce. Now compute is joining that category because modern systems increasingly need computational capacity the way older systems needed fuel or machine power. AI needs it, logistics needs it, finance needs it, defense needs it, media needs it, science needs it, business software needs it, governments need it. That means compute is no longer just a technical feature. It is an input. And once something becomes a critical input, the infrastructure behind it becomes strategically important. That is why data centers are moving closer to the center of economic power. They are becoming the places where digital capacity is turned into usable output. One reason this shift feels surprising is that the language of the internet hid the hardware. The cloud sounded light, flexible, abstract, everywhere and nowhere at once. But the cloud was always physical. It always depended on server racks, cooling systems, substations, backup power, network cables, real estate, engineering teams, and round-the-clock maintenance. Now that physical reality is harder to ignore because demand is rising so quickly. AI workloads, storage needs, video traffic, enterprise applications, real-time processing, and machine-to-machine communication are all increasing pressure on the system. So what once looked like invisible convenience now looks more like industrial scale. And industrial scale changes how people think about investment. AI is one of the biggest reasons data centers are being reclassified in economic importance. Large AI systems require extraordinary amounts of compute. That means more servers, more GPUs, more energy, more cooling, more networking capacity, more CapEx, and more facility expansion. This changes the economics because a data center supporting ordinary web traffic is not the same as one supporting heavy AI inference and training. The density rises, the power demand rises, the cooling challenge rises, the cost rises, and once enough of the economy starts competing for that capacity, data centers stop looking like background utilities. They start looking like strategic bottlenecks. That is what AI did. It made the physical layer impossible to ignore. One of the clearest signs that data centers are becoming industrial infrastructure is the pressure they place on electricity. Data centers do not only need power, they need reliable, continuous, high-volume power. That makes them different from many ordinary commercial buildings. They behave more like industrial loads. And when more data centers cluster in one region, they can begin competing directly for grid capacity, substation access, transmission upgrades, and power contracts. That is important, because once electricity becomes the bottleneck, data center growth is no longer just a software story. It becomes an energy story. And energy stories are political, capital-intensive, and geographically decisive. That is one reason this sector is getting so big. It is colliding with the hard limits of physical systems. It is not just electricity. Data centers also need land, cooling systems, water access in some models, construction materials, and local permitting. That means digital growth can create very physical local battles. Where should facilities be built? Who gets the power? Who pays for grid upgrades? How much water is used? What happens to local land values? How should communities weigh jobs versus resource strain? Those are industrial questions, not abstract tech questions. That is why data centers are changing local economies as much as digital ones. A region that attracts major facilities may gain investment, construction, tax base, and strategic relevance. But it may also face resource pressure, public resistance, environmental scrutiny, and infrastructure competition. That is exactly what happens when a sector becomes industrial. Once compute becomes a critical input, companies begin making location decisions differently. Where is power available? Where is land available? Where is permitting easier? Where is climate favorable for cooling? Where is fiber strong? Where can expansion happen fastest? Where is policy supportive? That changes economic geography. Certain regions become more valuable not because they are financial capitals, but because they can host digital infrastructure at scale. This is how industrial maps change. Old industrial eras favored coal, rail access, ports, steel, labor concentration. The new digital industrial era may favor power availability, cool climate, grid resilience, fiber connectivity, and political willingness to build. That is a real shift. And it means data centers do not just support geography, they help reorganize it. Investors are treating data centers differently too, not as niche tech real estate, as infrastructure. That matters because infrastructure attracts capital when demand appears durable. And right now, demand looks durable. Cloud demand is durable. AI demand is growing. Enterprise digitization is durable. Data storage demand is durable. Network traffic demand is durable. That creates a powerful investment thesis. If data centers are the physical base layer for multiple long-term growth systems, then owning, financing, building, or powering them starts to look like core economic positioning. This is one reason the sector is expanding so aggressively. The capital markets increasingly believe that compute demand is not cyclical noise. It is structural demand, and structural demand changes valuation. This is where the story becomes bigger than business. If data centers support AI, cloud services, financial systems, communications, defense systems, and national digital capacity, then they stop being ordinary real estate. They become strategic infrastructure. That means governments start paying closer attention, not only for tax reasons, for security reasons, for industrial policy reasons, for competitiveness reasons, for resilience reasons. Because a country that lacks enough digital infrastructure may become dependent on others for core capability, and dependence in strategic sectors is rarely treated lightly. This is why the data center story sits at the intersection of technology, energy, national security, real estate, capital markets, and industrial policy. That is not background infrastructure. That is strategic infrastructure. Just like older industrial cores, data centers depend on complex supply chains, chips, transformers, cabling, backup systems, cooling equipment, construction labor, power electronics, networking hardware, specialized materials. That means expansion is not frictionless. If one part of the supply chain gets constrained, deployment slows. If transformer lead time stretch, power build-out slows. If chip supply is tight, compute build-out slows. If skilled labor is scarce, construction slows. If grid connections take too long, the whole project timeline shifts. That matters because rapid demand does not automatically produce rapid capacity. Industrial systems still take time to build, and bottlenecks still matter. So even in a digital age, the pace of growth remains partly governed by physical coordination. That is another side. We are looking at a real industrial sector. This is one reason data centers can be misunderstood. They may not always feel like old industrial centers in labor terms. A steel mill, car factory, or port system might employ large visible workforces. A data center may create major capital intensity without the same scale of direct labor. That can confuse people. It looks smaller socially than the economic role it plays. But capital-heavy infrastructure can still be economically central even if it is not labor-heavy in traditional ways. Pipelines are like that. Grid systems are like that. Ports are like that. Telecom backbones are like that. Data centers fit that pattern. They are high-value, resource-intensive, strategic nodes whose importance exceeds their visible workforce. That is another reason the comparison to old industry can be easy to miss. Data centers are becoming the new industrial core because modern economic power increasingly depends on physical systems built to generate digital capacity. Compute is becoming an input. AI is accelerating demand. Electricity is becoming a constraint. Capital is treating the sector like infrastructure. Governments are recognizing the strategic implications. And geography is beginning to reorganize around where this capacity can be built. That is the deeper pattern. The digital economy did not escape the physical world. It rebuilt dependence inside it, and data centers are where that dependence becomes visible. The modern economy may look more digital than industrial, but underneath it, a new industrial core is forming. It is built from power, land, cooling, chips, fiber, machines, and buildings designed to keep computation running. That is why data centers matter so much now. They are not just where the internet lives. They are becoming one of the places where economic power is made possible. And in the years ahead, the regions, companies, and countries that control enough of that capacity may shape far more than technology. They may shape the next layer of industrial power itself.